No, it was per day.
All right.
Like 5 answers.
Okay, we're going to do some even more fun chain rule problems today. Ones that look like this.
I'm excited.
All right, and our directions on all of these are just to find the derivative. I didn't write it down, but.
There's more numbers than there are letters. What the heck? It's like an alphabet.
Wait, I think you just said that wrong.
Oh, wait, no. There's more letters than there are numbers. It's alphabet.
Yeah.
Oh, yeah.
All right, so the first thing I would do with this before I started, and actually, there's two ways you can deal with this. We'll look at them and see what, we might do one way and one the other and see which one you guys like better. I would write this as x squared plus 4 to the 1/3 power. So this, you can deal with this two ways. You can use quotient rule for this, or you can move that up to the top and use a negative exponent and use product rule. So I'm going to do the first one with quotient rule, and then we'll do the second one using that product rule so you guys can see the difference between the two and decide which one you like to do better. It really, the way you simplify is a little bit different, but it's going to give you the same answer in the end. So if we want to use quotient rule for this, when we take the derivative of this, we'll have low, which is x squared, plus 4 to the 1/3 power, times the derivative of the high, which is 1, minus high, which is just the x, times the derivative of the low. This is where you've got the most complicated part of this. You have to use chain rule here. So you're going to have 1/3 x squared plus 4 to the, what's my exponent going to be? Negative 2/3, because you're doing 1/3 minus 1 there. Then you got to multiply by the derivative of the inside, which would be 2x. And this will be all over x squared plus 4 to the 1/3 squared. I'm going to label these parts. Really shouldn't use F and G, but it's okay. So, oh wait, wrong color. So you got low, which is G right here, times F prime, and then we got F times all of this stuff right here is G prime over G squared. So everybody see where everything comes from there? Yeah. So what we have to do now is we have to, like, if it were free response, we could stop here. You're done. You've taken the derivative. You wouldn't have to do anything else necessarily. This is more likely to be found on a multiple choice question or somewhere where you're going to have to plug a number in later and it's going to help to simplify. So if we're going to simplify this, I'm going to just clean it up a little bit first. So this first part would be x squared plus 4 to the 1/3 power minus, and then remember all of this is multiplied together. So I've got this x, this 1/3, and the 2x can all be multiplied together. So that would give me 2/3 x, switch colors, 2/3 x squared times x squared plus 4 to the negative 2/3 over x squared plus 4 to the 2/3. Now, you should be noticing that we got this x plus 4, this x plus 4, we got one in the bottom also. So we probably need to like factor that out. So in that numerator, you want to factor out the lowest exponent of your x squared plus 4. So you're going to pull out an x squared plus 4 to the negative 2/3 power. So that means you're dividing each one of these terms by x squared plus 4 to the negative 2/3. So whenever you do that, I'm going to do this over to the side so we can think about it a little bit. When I have x squared plus 4 to the 1/3 over x squared plus 4 to the negative 2/3, what can I do with that negative exponent? Move it back up to the top, which would give me x squared plus 4 to the 1/3 times x squared plus 4 to the 2/3. What do I do when I've got those things? Add them together, which just gives me x squared plus 4 to the first power, right? This should always happen on these problems where you end up with something that's like a whole number. So whenever I do this, I just have x squared plus 4 for that first part, right? That's this first part right here. What's going to happen here where I have x squared plus 4 to the negative 2/3 over x squared plus 4 to the negative 2/3? Those cancel out, so I just have minus 2/3 x squared. You can subtract. So if we were doing like 1/3 minus negative 2/3, it would be like 1/3 plus 2/3, which gives you 1 there. So definitely you don't have to like write this over to the side. Here I'm just trying to make sure everybody's following what we're doing there. But that's pretty much always going to happen. We do not divide the bottom here because we're not reducing, although technically I guess we could do it that way. You could do it that way. What I have done is I've like factored this out front, so I'm pulling that out front. I guess technically, Troy, we could do that, and then we wouldn't write it here, and we'd get this something different in the bottom. If you divided the bottom also, it would work if you did it that way. It's just really just like different ways of thinking about that, because it is okay to divide like top and bottom by the same thing, so that would be all right. So I'm going to combine these right here. I'm also going to take this and I'm going to move it back down to the bottom, right, because it has a negative exponent. So this is 1 x squared, and I got to subtract 2/3 x squared, so that will give me 1/3 x squared plus 4 over, when I move this back down to the bottom, I can combine those two things, and I will get x squared plus 4 to the 4/3 power. And you will probably see them do one more thing to this because we don't like to have fractions inside of fractions. So that 1/3, I would really like to get rid of that 1/3 there. To do that, I could multiply the top by 3, which would get rid of the 1/3 because 3 times 1/3 is 1. And if I do that, I must also multiply the bottom by 3. And so that would be x squared plus 12, if we distribute that, over 3 times x squared plus 4 to the 4/3. And this is probably where you're going to see them leave it. They might do something like change that 4/3 back to a root or something. But probably right there is where you're going to see them leave it. It would look like this, x squared plus 12 over 3 times. You would have the denominator, the bottom of the fraction is the root, so that goes out here, and then you'd have x squared plus 4 to the 4th power, like that. So you might see them write it like that also. Okay, questions? Yes. They could give that to you not calculator active. They would give you something that you can take the root of. So like for example, well, that's not an easy one for me to think of the number that would make that work. Well, if you put a 2 right there, then you would, so like they might ask you to find f prime of 2, which means that you would be doing 2 squared plus 12 over 3 times the cube root of 2 squared plus 4 to the 4th power. So, of course, that'd be 4 plus 12 over 3 times the cube root of 8 to the 4th. And so, if you try to do 8 to the 4th, you're going to get a huge number, and then you're not going to know what the cube root of it is. But when I've got cube root of 8 to the 4th, that is the same as the cube root of 8 to the 4th power. So cube root of 8 is 2, and 2 to the 4th is 16. So you'd have 16 over 3 times 16, and that would just cancel out. You get 1/3 for that. So there is a good chance that you could see that on free response where you actually have to plug in a value for that. And if they do this, if it is free response and you have to plug in a 2, you could simplify it all the way down. It makes it easier to do this. But if I go back up here to the very beginning and plug in a 2, I could also do that. You don't have to simplify it to be able to plug in a number. So it really just depends on like what looks easiest to you at the time. All right, let's try this one, and let's use a different method on this. I might like this second way better. You guys certainly can decide which one you like best. So this time, what I'm going to do for this one, we've got 2x over the square root of x squared minus 4, which is 2x over x squared minus 4 to the 1/2. I'm going to write it like this, 2x times x squared minus 4 to the negative 1/2. Like I said, I think I like this way better, but you guys decide which way. I think it makes it a little easier to simplify. So what I'm going to do this time is I'm going to use a product rule for this because these two things right here are being multiplied together, right? So here is my, first equation. Here is my second equation, and I'm going to be taking the derivative of using the product rule. So if I do that, f prime of x is going to equal f, which is just my 2x, times g prime. Here is where you got to do the chain rule. So you will have negative 1/2 times, leave the inside the same, x squared minus 4 to the, what will I get for that exponent? Negative 3/2. I'm doing negative 1/2 minus 1, which gives us negative 3/2. And I've got to multiply that by what? 2x, the derivative of the inside. Okay. So that is just my first function times the derivative of the second. I have still got to do plus the second, x squared minus 4 to the negative 1/2 times the derivative of the first. What is that? Just 2. So that was in my 2 pieces there. And there's no derivative, no denominator on this one because you just use negative exponents instead. So if we clean this one up a little bit before we try to simplify, Here I've got 2x, a negative 1/2, and another 2x. So 2 times negative 1/2 times 2 is going to be negative 2. And I've got an x here and an x here, which gives me x squared. And then I've just got my x squared minus 4 to the negative 3/2. And then I'm going to just write this one, 2x squared minus 4 to the negative 1/2. Your derivative is taken at this point. If it was free response, I would stop here. I would not go any further unless you need it for something else that you're going to have to plug in. Or even if you have to plug in, you could do this here, although probably going to want roots for that. So probably, though, these are going to be on multiple choice. So I should be seeing that I've got x squared minus 4 here, and I also have an x squared minus 4 here. Those match. So I can factor out the lowest exponent for those. What is my lowest exponent? Negative 3/2. So I'm dividing both of these by x squared minus 4 to the negative 3/2. So I will write x squared minus 4 to the negative 3/2 out front. And then for that first expression there, I've got x squared minus 4 to the negative 3/2, and then I'm dividing out x squared minus 4 to the negative 3/2. Those just cancel each other out, and we are left with the other piece that it's multiplied by, so the negative 2x squared. Now for the second part, that is not what is going to happen. So you can think about this several different ways. You could think about subtracting your exponents. Negative 1/2 minus negative 3/2 would be like negative 1/2 plus 3/2, which will give you 1. You could think about moving this back up to the top where you have to do negative 1/2 plus 3/2. Again, you get 1. So what happens here is you got 2 times x squared minus 4 to the first power, which you don't have to write that first power there. Is everybody okay there? You always do top minus bottom. So you're doing negative 1/2 minus negative 3/2, like that. So this would become positive because you got a double negative there. So that would be 2 over 2, which will give you 1 for that. So it's always top minus bottom on that. And it usually becomes 1. Troy, there could be some different instances where maybe not, but for most of the problems we do, it usually becomes exponent of 1. So I'm going to send the negative exponent stuff to the bottom. I'm going to distribute right here. So I'm going to have negative 2x squared plus 2x squared minus 8 over x squared minus 4 to the 3/2. And the negative 2x squared and the positive 2x squared are going to cancel out. I'll just get negative 8 over x squared minus 4 to the 3/2. There. Probably be left like this. There's a chance they also might do this. They might have the square root of x squared minus 4 to the 3rd power. They might write it like that. That would be equivalent. Definitely when you're doing the assignment for this, look at the back of the book on those odd problems and try to get it to match. I kind of like this better than doing quotient rule. Because you don't have like a denominator you have to worry about or combine. But certainly can use quotient rule if you would rather. Questions? couple more to do. Yep. Oh, wait. You guys try this one on your own. Eight minus negative 1/2 would be negative 4. Although, okay, all right. So if you're doing that, I don't know if you've done it right. Check with your neighbors, see where they're at. See if you're on the same track or if you're not.
Did you go back and do yours from last year?
What?
Yes, thank you.
Oh, yeah.
Mine weren't as high as I thought they were.
Mine were super good.
Yeah.
I like them for 5 or something.
They weren't as good
Yeah,
as they were last year.
Yeah.
Right, you have predicted
Yeah.
the plus and minus.
X squared
Yeah.
minus 3.
I'd give myself a plus if it was 52 and I got a 53.
Right.
Percentile, that would be a lot worse.
They're doing
Changes
like,
from
yeah.
year to year.
And see, mine was, I didn't have, my ones that were negative were not negative much. They were like negative 1, negative, they were, my negatives were not very negative. I didn't have any.
No, you got a negative
like
3x
you had,
to the third there.
where you just had to try it all.
Because there's a
Mine
negative
was
1/2
like
that you want in the beginning when you
it's the only year I
take the
actually
product
felt like I was teaching math.
3x squared
And
times negative 1/2.
most years, I feel like about half the class is getting it, and the rest of them are not at all. So that's about how I feel in 3 times.
You still come out close.
Yeah, you're pretty good. All right. Here is what you should have. You may not have done it the same way that I did it. If you use the quotient rule, your work is going to look different. So definitely if you stop here, before I divided by that red stuff, if you stop here and you have the negative exponents,
You done something wrong at the end.
what did I do?
3x. When you put it 3x, it should be 9. It should be 6.
Oh, you're right. Ugh, I did mess it up.
Bathroom pass.
You do not, because I make too many mistakes like that. That bathroom passes are only for published works.
We
no.
wrote it down.
I did write it down, but all right. So that should be a 6. But otherwise, now this is what you should have. I use product rule. So if you use the quotient rule, your work will look different. But you should still get down to this. If you get this right here, you have taken the derivative correctly, but you maybe have not simplified correctly. I do want a common denominator on this because most of the time this is going to be on free multiple choice, and they're going to. Now, as far as how you leave it, whether you leave it like this, whether you factor out that 3x, that's not really important, although don't put a 9 right there like I did because that's wrong. You might have even changed that denominator back to a root. That's perfectly fine there. So like once you get to this point, if you have this as your answer or this or some variation of that, it should be fine. Now, if you're not even getting to here, make sure what you've got here, because this was your first function. Use purple for that. This is the second function. So right here you've got your f times, here's where the big work is, g prime. You have to use a quotient, you have to use a chain rule for that. So you got negative 1/2 x squared minus 3 to the negative 3/2. Then you got to multiply by the derivative of the inside, which is the 2x. Then you just write this down without doing anything to it and multiply by the derivative of the first. So I'm going to give you a second to look over yours and try to fix it wherever you may have messed up. Yeah.
Negative. It's negative, Jeremy.
Negative.
It's not negative. Eat up egg. It's not egg. It's not egg. It's egg. It's not A-I-G-G.
It makes an A sound. Phonetic
Why would they have an E if you're always saying A for E? There's an E there for a reason. No, you do need the.
All right, questions on this beyond how Jeremy pronounces his answer.
Illinois.
That's silent.
All right. Okay, let's look at this last one. All right, this one is going to be a little bit different. You have some options on how to deal with it. So for this, you can do a chain rule inside of a chain rule. If you do a chain rule inside of a chain rule, then you must do 2 this stuff to the first power, and then do quotient rule over here. Your other option on that is to like write it as the top squared and the bottom squared. Which one do I think is going to be easier here? Or you could make it a product. Which one do I want to do? Luke is saying product. I guess we can do that. So this would be 3x minus 1 squared over x squared plus 3 squared. Right? Whenever you have a fraction squared, you square the top, square the bottom. And Luke does not like to do quotient rule with this. So he wants to do 3x minus 1 squared times x squared plus 3 to the negative 2. No, you can't combine those. Because of that negative exponent right there. Yeah. Yeah. And those two things are not the same, so you can't, like if it was 3x minus 1 squared and 3x minus 1 to the, second or something, you could put those together, but it's not the same thing inside the parentheses. So if we want to do the derivative here, we've got to use a product rule here. So here's our first expression and our second. So we would do the first, 3x minus 1 squared, times the derivative of the second. You must use a chain rule for this. So it's negative 2 times x squared plus 3 to the negative 3 times the derivative of the inside, which is 2x. So we have done our first function times the derivative of the second. It's easy to feel like you're done, but you're not. Now we need the second, x squared plus 3 to the negative 2 times the derivative of the first. You got to use chain rule again here. So it'd be 2 times 3x minus 1 to the first power times the derivative of the inside, which is 3. You have times 3. I got it right.
I did that.
Yeah, if you sometimes you might like have those two things switched. It's okay. No, it's fine. Yeah, if you want to keep sometimes students like to do like kind of like you would do the quotient rule. They like to do like the second, d high, like they treat that second one like it's the denominator. So they'll do basically this part first and then this part. But just make sure you got one function times the derivative of the other plus the other times the derivative of the first. But, yeah. Yeah, I just go in the same order every time. I don't like switching it up. It messes me up. But if you can, as long as you have F times G prime and G times F prime.
Just multiply through, just do F prime, G prime, F, G.
No, because it's added in between. Yeah. So it doesn't matter, like, F has to be multiplied by G prime, and G has to be multiplied by F prime. It does not matter which one of those comes first, because addition, we can switch the order. And it doesn't matter within each one whether F or G prime comes first, or G or F prime comes first. But you can't have, like, F times G and the primes times each other. You can't switch that. So if we clean this up a little bit, we're going to have negative 4x times 3x minus 1 squared times x squared plus 3 to the negative third. Over here, we will have 6 times, I'm going to write my 3x minus 1. I'm going to keep that first power even though it's unnecessary to write. And then I've got x squared plus 3 to the negative 2. It does not matter because everything here is multiplied. This is multiplied by this and this. Everything's multiplied together. So typically you're going to see that negative 4x written out front. Now, we should be noticing we've got a 3x minus 1 for both of these. We also have an x squared plus 3 for both of these. So we can factor that stuff out. We want to take the lowest exponent. So for the 3x minus 1, we're taking out a 3x minus 1 to the first power. Because that's our lowest exponent for those. And for the x squared plus 3, we're going to take out that negative third power. So this is like we were doing factoring that other stuff out, but we're taking two things out this time. So we will have a 3x minus 1 out front. We'll also have an x squared plus 3 to the negative third. And then we got to figure out what's going to be inside of these parentheses here. So we have negative 4x stays. Then I've got 3x minus 1 squared over 3x minus 1. One of those cancels here, and I just have a 3x minus 1. And both of the x squared plus 3 to the negative third are going to cancel each other out. For the second one, I've got that 6. The 3x minus 1's cancel here. What will I get for my x squared plus 3's? Just x squared plus 3. Stop there for a second. Questions? Alright, so basically all I have left to do is clean up this stuff in those brackets, and I might want to send this back down to the denominator. So I will have 3x minus 1, and then right here I'm going to have negative 12x squared minus, or plus 4x plus 6x squared plus 18. And I'm going to move that x squared plus 3 to the third back down to the bottom. And so if I combine my like terms here, 3x minus 1, I will have negative 6x squared plus 4x plus 18 all over x squared plus 3 to the third. And I am pretty sure there is nothing else you can do to that.
If you want to, you can expand.
You could possibly expand, like multiply that back together, but usually you will not see them do that. Usually they keep it in that factor form. Definitely as you're working, check your answer. It's in the back of the book and try to get them to match whatever's there. Okay, questions? Alright, so, let's see. I think I changed this on the... I think I changed this on Canvas, so it may be even less. It might be even less.
Let's go with less than stuff.
Let's see. Where are we at? We are 23rd. Alright, so here's your assignment. 27, 28, 29, 31, 33.
That's 5.
You got 5 questions.
2 less than 7.
27, 28, 29, 31, 33. So you got a few minutes. Go ahead and get started. You should be able to get maybe a couple of these done before you go, I hope. They take a while.